This lesson is on graphing. We're going to look at not only some of the standard types of graphs we have here at the beginning of Honors Algebra 2, but we're also going to look at some of the formats we have for listing the information with it. So we're going to start here with looking at introducing the format of the notes we're going to take. This is called Cornell notes, which are 2-column notes formats. So what you're going to look at is you're going to always look for the topics on the left-hand side and the details to go with it on the right. So if you're looking to review, look for the topic you need to review, find the information then on the right. So we're going to start with looking at some of the inequalities that you've had before in algebra and just reviewing over those and then putting them into a certain format. So as we look at this, let's go ahead and talk through these inequalities. So this inequality here says we want x between 3 and 6, include the 3, don't include the 6. So if we start here and make this 3, 4, 5, 6, and 7, so you'd put a solid dot on 3 because it has the or equal to, and you put an open dot on the 6 because it does not include that one. It's not or equal to, doesn't have the line under it, and then shade everything in between. Remembering that it includes all the decimals in between, like 3.9, 5.2, all those decimals are included between the numbers as well. If we were to graph this greater than symbol, we go ahead and label our graph, so 3, 4, 5, 6, 7, put an open dot on the 4 because it's not or equal to, and then shade to the right side because it's greater than. The less than or equal to, we'll say 5, 6, and 7 here on the graph. Put a solid dot on the 7, and we're going to shade to the left because it's a less than. The closed dot means it's going to be or equal to. And then lastly here, let's say I have -5 here. I go 0, -1, -2, -3, -4, -5. Put a closed dot on the -5. And then shade to the right side because it's a greater than part of it. All right, so now we're going to introduce some new notation. And this new notation, this is called interval notation. I'll introduce it and then come back and show you what it looks like here. Interval notation looks like an ordered pair, but instead it identifies what the range of values are covered on graphs like this. So if you're looking at a graph and you see, for instance, a bracket either on either side here, this would be like a closed dot. And if you see a parentheses, that would be an open dot. And then what you're going to do is put it into a ordered pair look, but it's not an X and Y. It's instead it's got an interval or a range of X values. So let's take a look at this. If I had, let's say, -2, 1, and it looked like this, this is the same as the inequality. X is less than or equal to 1 and greater than -2 because the open parentheses means it's an open dot like that one, and then the closed bracket means it has the or equal to on it. So let's go back and identify each of these with the interval notation. So for this one, we're going to first of all put 3, 6, because that's the range of values between 3 and 6. Put a bracket on 3 and a parentheses on 6 because it includes 3, does not include 6. Here, for the x values greater than 4, the 4 is the smallest number, and then it goes off to infinity. So you list infinity. You never actually get to infinity, so don't put a bracket on infinity. Instead, always put a parentheses. This one, 7 is the largest number, so it's going to have a bracket on this side. And then we go off in the negative direction, an infinite amount. And so you put negative infinity here with a parentheses on that one. And lastly here, -5 is our smallest number. So you put a bracket on that, and then you go off to infinity. That's a parentheses for it. All right, so that's interval notation. Let's talk now about set builder notation. Set builder notation is a formal look. This is the formal way. Formal way we list these inequalities. Interval notation is more like a shorthand. It's the quick and easy way to do it. Formal notation, all it does is it adds a little formality to it. It has a brace, and then you usually have an X with a slash, and then the rule that goes with it, and then you close it with the brace. This slash means X such that, and then you give the rule for it. And I'll illustrate it when we do these up here. But the idea behind it is just to give a little formality to how we present the information. So this one here would just be listed as a brace X such that, and you just put the rule in, -2 less than X less than or equal to 1. Right. Just so you're aware, this could also be a colon. Sometimes mathematicians will use a colon instead of the slash for it. So I'll use both up here. To list this one, you go back up to this rule and you just put the brace X such that 3 is less than or equal to X, which is less than 6, and then finish your brace. This one, just put the brace, and I'm going to use the colon this time just to emphasize that, and then put your rule down, X is greater than 4. This one here, just put X such that, I'm going to use the colon again, X is less than or equal to 7. And then lastly, I'll use the slash for this one, X such that X is greater than or equal to -5 for the interval notation, or the set builder notation. Now what you will be expected to do is, given one of these, be able to convert it to the other. So we're going to do conversions between the two of those until you get used to both notations and how we use it. Now, let's move down here to an actual graph. Okay, we're going to talk about functions quite a bit. This graph is of a function. A function is defined as, for every input, there is exactly one output. Typically, we think of the inputs as the X's, the outputs as the Y's. So looking at this, we'll talk about domain and range. The domain, when we look at a graph, let's talk about the graph first. So let's remember that how we do graphs is we usually list them with ordered pairs. So let's go ahead and look at these 3 points, because that looks like important points on this graph. Remember, the context is so important. In interval notation, we're talking about a range of X values. Here, when I list an ordered pair, I'm talking about an X and a Y instead. So it's not the range of X values, it's actually an X and a Y value. Context makes all the difference. If it's a point on a graph, it's X and Y. If we're talking about domain and range or other range of values, that's going to be the interval notation. Right, so this is at -1, 2, 3, 4, 5, 6, 7. So -7, and it goes up to 1, 2, 3, looks like up to 4. This point here goes to -3 for the X, and it goes down to -1 for the Y. And this ordered pair up here, so it goes out to 1, 2, 3, 4, and up to 1, 2, 3, 4, 5, 6. So those are my ordered pairs, X's and Y's for it. Now domain is the list of the range of the X values. So this would be the range of X, the X values are what we're listing when we talk about the domain. The range is the Y values. So look at the x values here. What is the smallest x value and what's the largest x value in this graph? Well, the smallest x value is this -7, and the largest x value is over here at this 4. So it goes from -7 all the way to 4 for my domain. It includes those x values, so I'm going to put as interval notation -7 to +4 for our domain. Now for the range, it's the y values. We're going to look at what the y values go from the up and down. So y values go from the bottom up to the top, whereas x's went side to side. So the y values, the lowest here is going to be a -1. The highest y value is a 6. So I'm going to put from -1 up to 6 for my range. Now intercepts are our next important idea here. So intercepts talk about where the graph crosses the axis. Where the graph crosses an axis. All right, let's look at these up here. So we're going to start with the x-intercepts. If you look at the x-intercepts, it crosses right here and right here. Those are my x-intercepts. I'll abbreviate here, right there, and right there. That's at -4 and -2. So my x-intercepts, -4, x equals -2. My y-intercepts, on the other hand, where it crosses the y-axis, there's just one of them. Crosses the y-axis here. And so my y-intercept is at y equals 2. So that gives me the information when it comes to this graph, which is a function. It tells me what the domain range is and where my intercepts are. Let's take a look at how we describe some of the intervals of when this graph is positive and negative and increasing and decreasing. So first of all, I'm going to outline when this graph is positive. It looks like it's positive here until we get here to -4 for the x. Then it goes negative after that. And then it picks up going positive again over here at -2. So when we're looking at the positive intervals, this is when it's above the x-axis. So above the x-axis, it starts here at the -7. -7 is above positive. But then it goes to -4, and notice we get to -4, it doesn't include the -4 because -4 has a y value of 0, neither positive nor negative. The negative intervals, on the other hand, are below the axis. The x-axis. And this one we'll look at, let's see, we'll make this one green. Okay. So here, this is the part where it's below the axis, and that goes from -4 to -2, that interval. And then it's not including those because those are 0 values at -4 and -2. And then it picks up and goes positive again. So we're going to list another positive one here. So it starts at -2, does not include it because -2 is a 0 value, and it goes off to 4 on this and ends at 4 including that value. So here are my positive intervals, that's my negative interval for it. Now increasing and decreasing talks about whether it's going up or down, not whether it's above or below. So notice for increasing would be going up. Let's take a look at this one in red. So going up would be from here up like this. So that starts here at an x value of -3, and it goes up till we get to the end where x is equal to 5. So from -3, to 4 is an x value. Now on this, so notice with -3 to 4, it doesn't include those two because at this point it's not going up or down, it's just changing direction. Decreasing, on this one, we'll do this one in blue, so this is where it's decreasing, there to there, and so this would be when it's going down, and it decreases starting at my -7, and it decreases all the way into a -3. Okay, those are parentheses because at the end points it doesn't increase or decrease. Now, last formula we're going to look here at is going to be average rate of change. An average rate of change, you want to think of slope. That's what rate of change is. But we want to do the slope between the beginning of the graph and the end. Alright, so when we look at this, if you remember what slope does, okay? So here, this point here is our beginning. This is at -7, 4. And over here, our ending point is at 4, 6. So now those are ordered pairs. These are intervals, okay? Those are ordered pairs on the graph. So let's go ahead and find the slope. Slope is going to be the difference of the y's, so 6 minus the 4. And over the difference of the x's, 4 minus the -7. So 6 minus 4, 6 minus 4, and 4 minus -7. You get 2 over 4 plus 7, because minus the negative is 11. So our average rate of change is 2/11. That's basically saying on this graph where we're doing this graph, it's saying how fast is it changing between the beginning and the end, so you're getting an average of it. Now, lastly, let's take a look at the standard graphs we have in the beginning of Honors Algebra 2. So we have linear, quadratic, absolute value, and constant. We'll be looking at this chapter. Linear graphs are where you have the graph is a line. A quadratic is where the graph is a parabola. Absolute value is where you have a V shape to the graph. And a constant is where you have a horizontal line. This gives not only the shapes of it, but gives all the information. Let's highlight a few that you can look through the rest of it. For instance, domain of a line, if you look at the line here, for the domain, keeps going right, keeps going left forever. So that's why it's -infinity to infinity, all real numbers. The range is the same because it keeps going up and it keeps going down. So the range of this is also all real numbers, -infinity to infinity. But look at the contrast to the parabola. The parabola, it does have a range that stops at 0. It includes 0, but it goes up from there. But people forget that this graph is not only going up, but it's also going out. It's going to the right and to the left because of how the arrows are getting wider. So the domain is all real numbers because it keeps going further to the right and further to the left. You got to remember that when you have graphs going to the side. So our different problems here, we basically have looked at our standard graphs, we've looked at interval notation, set builder notation, and some formulas to go with that. This will help us get started with some of the vocabulary and some of the notation here at the beginning of Honors Algebra 2.